Let's start. Hello all. Let's start with the today's DSA Journey with this amazing DSA sheet by dsa.chaicode.com. Use this link to get a 7-day free trial. Okay. So today our question is this: search in a rotated and sorted array. Given an ascending order array that has been rotated at one's unknown pivot, find the target value index of a target value in big O of log n time and returning -1 if it's not present. Okay, so this is our question, and this array is okay. This is the actual array. This is the actual array which is sorted, if you could see, but we are given a rotated array also. So if you see this part, we just take this part and rotate the whole part into the first, and then this first three part. Okay, first this part, then this part. See here, 4 5 6 7 0 1 2. We have to find a target, and what is our target? Find 0. Okay, so in this array we have to find 0. So what would be the brute force approach? Okay, so use a linear search. Just search the whole array and find the index where you find the target. Simple. A simple linear search for the brute force approach. If we write the solution, it will be like, given an array and a target t, so just for I starting from 0 to n-1 till the last index, just check one condition. If array of I is equal to target, then simply return that I, because we have to return the index. Otherwise, at the end, if we don't found any index, simply return -1. So this is our simple pseudocode. And yes, this is the complete pseudocode. So this is our complete pseudocode. And what is the time complexity? Big O of n. But in the question we are given big O of log n time. And in which case we got big O of log n time? We got big O of log n in binary search. So if you go to the question, this is the question. Here actually all of the details are mentioned, like how the index k is chosen because it is only in between the length. Then we just rotated it, and also we have to do it in log n time complexity. Okay, but how? First, I would like to take the array, and this would be our solution or pseudocode. Okay, let me just zoom in here. Yeah, so this is the array and this is our pseudocode. So what we are actually doing, so this array is already sorted one times. Okay, so if you clearly see, like if you just part this array, this portion, so this part is sorted, this part is also sorted. Okay, so if we somehow got to know that our target lies in which part, if suppose we have our target will become 6. So somehow if we land into this half, we can easily find this 6 because this whole portion is sorted. Okay, so we can easily apply binary search into this sorted space. Same otherwise, we are given our target as 0. So our target 0. So if we somehow reach this part, we can easily get into a portion where it is completely sorted part. Okay, from the 0 to 2. In this sorted part, we can easily get our search element into a simple log n time complexity. But the question is, how could we go there? We can use a binary search there. So let me do this, and this will be our pseudocode. So let me just smaller this up, yeah, or put it here, I think. Yes, this would be much more better. So first we calculate mid as usual. Okay, so if we calculate mid in this array, don't focus on this solution, okay, focus on this array. So if we calculate mid, it is something 1, 3, 4, 5, 6, 7. So it is some 7 by 2. Okay, it will be like 3. So 0, 1, 2, 3. So our mid will be this. After we get our mid, if we take our first binary search solution, that is 7 our target. If 7 our target, we just return that index, that mid index. Simple. But if somehow the value is sorted or the value is smaller, okay, so first we have to check one thing. That the value is given to us is smaller or not. But before checking that also, we have to first go and check that we are in a sorted condition or not. Okay, so if you see here, the logic is simple. The if array of low is less than, okay, if the array of low is less than array of mid, so it simply do a simple thing, that we get a thing like we have to get something like, see here, the array of low is actually less than array of mid. If you see here, it simply means that we are in a sorted part. So our mid into a position where the lower position of the array is actually sorted, or the left part of the array is actually sorted. Okay, we reach a position where the left part is already sorted. And when we got to know that the whole left part, which is from the starting to mid, is sorted, we just check one condition, that is our target is in between this range. So our target is simply 0. So is 0, this lies in this 4 to 5 4 to 7 range? No, it doesn't lies. So whenever the it not lies, whenever the value is not lies, so simply means in this portion the target doesn't lies. So simply what we do, we just do our low to the next element of the mid. Simple. This is how we do. Now we can again do a mid operation. Okay, so if we do another mid operation, it will be like 0, 1, 2, 3, 4, 5, 6. So 6 plus 4 by 2, which is simply 5. And our 5 is this one, and this is our mid. Okay, so now do the simple check. Like our mid is this one, and our 0 is this left. Okay, so from this left to the mid, is this part sorted? Yes, it is sorted. When it is sorted, put the high to the left. So currently our high put into the left. Okay, we got our things. Now if we again calculate mid, our mid will be the okay. If we again calculate mid, what will be our mid? Our mid will be this 0. This 0 will be our mid, and it is equal to our target, so it will return the mid here. So see, we just check, we just do all binary search operation, but in a something manner. So first we calculate mid, but also calculating mid, we are checking that we are into a sorted part or not. So we first go to our left part and check is our left part sorted from the low till the mid. If it is not possible, we will go to our right part, which is from the mid plus 1 to the high, and check the following conditions there. So this is simply our pseudocode. And what we are actually doing inside after checking that, oh, we got into a left sorted part, we just check one thing. Into the sorted portion, like the whole sorted path or the whole sorted part or the whole sorted portion, we are checking is our value belong to this low to mid or high to mid. So if the left part, we just check low to mid. If it is a high part, which we will check that mid or high. So this, if the target in mid or high, okay, and here if the target in low or mid. This is the two simple thing we are checking. So let me go here. This one. So see, first we calculate the mid and we are checking if we got the mid value or not. So whenever we don't get the mid value, we go to the left sorted part. Okay, and in the left sorted part, we are checking that the target we are actually need, is actually between the low or mid or not. If it is low, between low and mid, so if our target is between low or mid, simple. Suppose, uh, okay, let me do it. So 1, 2, 3, 4, 5. Okay, so this will be our mid. This will be our low. Suppose this is our target. What we do in simple binary search? We do, this is our high, this is our high. We just do high minus 1. Same here. So if our target is between low minus low and mid, in between low and mid, see here also our target is in between low and mid, we do mid minus 1 to the high. Same we do here, mid minus to the high. And otherwise, if suppose our target is 4, okay, so let me just, this is high. So if suppose our target is 4, so what we do low equal to mid plus 1. Okay, simple. So same thing we did here, low equal to mid plus 1, and same thing happened for the right part also. But in the right part, we also make sure the right part is sorted. So for that, if we don't get a value, like we get a value like from the mid to the high. If we get the value in between mid to the high, suppose this one, okay, so suppose 4, okay, in a simple binary search, suppose 4 is our target. So our our search space is mid to high, so we do low here. Same thing we do, low equal to mid plus 1. And the same thing, like if we got to, our high will be there. Simple binary search, but we apply it 2 times. First we go to the left part and check that, okay, the left part is sorted or not, and if not, then we go to the right part. Simple thing. So if we evaluate this, it should work. Yes, it is working. So this is our complete pseudocode. Now if you see the code, it will be as same as the pseudocode. Okay, I will write the code again, but don't worry. This is simple as the pseudocode, and it is proper commented, this code. I just commented it every time. Okay, so this is our pseudocode. Okay, so what if we just write down the code, because we already had the code here. Let's write down it. So what we are taking low and high. What is low? Low is simply 0. And what is high? Okay, high is simply nums dot size minus 1, which is last index. Simple loop while low is less than equal to high. This is our binary search condition. Then calculate mid. I will calculate mid in our this fashion, high minus low by 2. Okay, now simply do what we are checking. First, check if the, or I just shrink it down, check if the value present in mid. Okay, so if nums of mid is equal to our target, then simply return the mid. Simple. We need to go give the output of the index, so we do mid. Now first we have to check the left part, like if the left part is sorted or not. Okay, check the left part is sorted or not. Like if nums of, sorry, nums of low is less than equal to nums of mid, it simply means our left part is sorted. Simple. Our left part is sorted. It simply means. Now check if the target present in the range of low mid. So how we do that? If nums of low is less than equal to target and nums of mid is greater than equal to target, it simply means that the target present in the range of low and mid. Okay, so if the target present in the low and mid, what we do, if we go like this pseudocode, I will make it bigger and also I will write it here. So if we found the target, we do a high -1. Okay, so let me do it again. So if this is the low, this is the high, and this is the mid. Okay, so we found that 2 is in between low and mid, so we just put our high into mid -1. Simply our high equal to mid -1, and else simply do low equal to mid plus 1. Okay, and now we have to check the right part. So in the if condition we check the left part, and in the else condition we check the right part. Simply do check if the target present in the range, and what is our range? Simply mid till high. Okay, so how could we check that? If nums of mid is less than equal to target and nums of high is greater than equal to target, it simply means that it is present in between the mid and the target. So this is the mid. So suppose if our target is 4. Okay, so it is in between the range of mid and high, so our left will move to this mid plus 1, not here. To our low will go to mid plus 1. Okay, and for the else case it will do high equal to mid -1. Simple. And at the end of this while loop, simply do a return -1. It simply means if we don't found a solution, it returns a -1. So this is our solution. Let's run it and check it. It's running. Let's submit it. Yes, it is submitting. Okay, 100%. So this is the solution. this is the solution actually we are given to you. And just actually if you want to remember what we did here, we did simple thing. Actually in this line I just sum it up in a sort manner. The array is rotated, so the whole array is not sorted. But because it originally sorted and rotated only once, whenever I pick the middle element, at least one half is guaranteed to be sorted. It is always guaranteed that we are given one half to be sorted. It is always guaranteed. The first identity that sorted half, we have to identify the sorted half. Since the half is sorted, I can check its boundary by determining whether my targets belong to. So we just check with this if condition, this if else condition here, this if else condition here. That is it possible to the target to be present in between this boundary? If does, I search there. Otherwise, I discard it and search the other half. Okay, simple. Since eliminating roughly half of the array every time, not half of the, roughly half of the, so the time complexity remain big O of log n. Okay, so this is a summarization of this whole concept. Okay, so just break the array into halves and then search it. Simple. So this is the question. Go use the question, use this set here, and use this link when you are using the set. Use this link, okay, so that you get a 7-day free trial. That's it. So use this platform. Thank you very much.